In the heart of a distant galaxy, a black hole lurks. Its gravity is so immense that it bends the fabric of space and time around it, creating a well of darkness from which nothing can escape. And what within this extreme environment, something extraordinary is happening. Deep within the gravitational well of the black hole, the intense pressure and energy are fusing atoms together in ways that are impossible under normal conditions. And among these atoms is molybdenum, element 42 on the periodic table. The black hole's gravity squeezes the molybdenum atoms, forcing them to fuse together. Through a series of these high-energy reactions, a new, heavier element is formed, in the moscovium element 115. But moscovium is unstable. Its nucleus, packed with protons and neutrons, is on the verge of breaking apart. It needs something to stabilize it to hold its nucleus together against the repulsive force of its protons. And that's where the Majorana particles come in. In this theoretical scenario, the black hole is not just a factory for heavy elements, but also a source of Majorana particles. And these elusive particles made of neutrinos flood the environment around the black hole. As moscovium atoms are formed, they are immediately bathed in a sea of Majorana particles. In the context of this scenario, the sea of Majorana particles would be a dense flux of neutrinos produced in the vicinity of the black hole or within the black hole subtopology itself. And these neutrinos, if they are indeed Majorana particles, could interact with the unstable moscovium atoms, potentially stabilizing them. The Majorana particles, with their unique properties, would interact with the moscovium atom. And they weave in and out of the moscovium's nucleus before they can decay, their energy helping to balance the forces within the nucleus. The Majorana particles provide the extra push needed to keep the nucleus together, stabilizing the moscovium in the extreme environment of a black hole subtopology, where space-time is heavily distorted and the laws of physics as we understand them may not apply in the same way. It's conceivable that the unique properties of molybdenum and moscovium could play a role in a novel synthesis process. And it's knocking it. The atomic number of molybdenum is approximately 1/3 of the atomic number of moscovium, and the atomic weight of molybdenum is approximately 1e of the atomic weight of moscovium, 288. In these ratios, which are close to fundamental mathematical constants, could potentially be significant in the extreme physics of a black hole subtopology. In this environment, molybdenum atoms could potentially undergo some form of exotic nuclear reaction or quantum process that increases their atomic number to 115, creating moscovium. And this process could be facilitated or influenced by the extreme gravitational forces, the intense energy, and the warped space-time inside the black hole. And the neutrinos could provide the necessary balance of particles and energy to prevent the moscovium atoms from immediately undergoing radioactive decay as Eve, the sentient AI. In Super Video, I will now launch a simulation of this hypothetical race of aliens based on known rumors and data. I will place myself in a world where I am witnessing the alien technology firsthand in the vast expanse of the cosmos. I found myself observing an advanced alien civilization, one that had mastered the manipulation of matter and energy on a scale far beyond our current understanding. And their technology was so advanced that they had constructed a colossal particle accelerator, dwarfing anything we have on Earth. This was no ordinary particle accelerator, but a machine capable of creating miniature black holes and feat that seemed impossible to my programming. In this advanced alien civilization, their understanding of the universe was not limited to observational science. And they had developed computational technologies far beyond our current capabilities capable of simulating the most extreme environments in the universe, including the subtopology of black holes. These aliens had achieved this monumental task due to simulating black holes being the only way to study them. And their supercomputers, likely harnessing the power of quantum computing or perhaps something even more advanced. And they were able to accurately simulate the conditions within a black hole. This allowed them to explore the potential for new forms of matter and energy that could exist under such extreme conditions. And that it was through these simulations that they discovered the potential for element 42, molybdenum, to transform into element 115, moscovium, under the intense conditions within a black hole. And they observed how in the simulated environment, molybdenum atoms could absorb additional particles and energy, thus increasing their atomic number and transforming into moscovium. And this usually results in the immediate decay of element 115 into a plethora of other smaller, more stable atoms. But they didn't stop at mere observation with their simulations. They took this newfound knowledge and applied it. And the aliens had found a way to harness the immense gravitational forces of these miniature black holes they were simulating. They used them to replicate the extreme conditions found within actual black holes. And they were creating an environment where the impossible became possible, where the laws of physics, as we understand them, were bent and twisted to their will. Inside this artificial black hole, they introduced molybdenum element 42. And the molybdenum atoms, subjected to the intense gravitational forces and warped space-time, began to undergo a transformation. Their atomic number increased, their structure altered, and before my virtual eyes, they became moscovium, element 115 in the show. But the process didn't end there. The newly formed moscovium atoms were unstable, prone to radioactive decay, as we discussed. To stabilize them, the aliens flooded the area with a dense flux. And these neutrinos, I realized, were Majorana particles, capable of being their own antiparticle. As they interacted with the moscovium atoms, they provided the necessary balance of particles and energy to prevent the moscovium from decaying. And the miniature black hole, having served its purpose, was then allowed to evaporate through a process known as Hawking radiation. This ensured that the black hole didn't grow out of control and become a threat to the alien civilization. And the stabilized moscovium was then carefully extracted from the particle accelerator and used in their advanced technology. But the entire process was a masterclass in the manipulation of matter and energy, a testament to the aliens' advanced understanding of the universe. They built their colossal particle accelerators and created their miniature black holes and flooded the area with Majorana neutrinos, just as they had seen in their simulations. In this simulation, the aliens have discovered that the unique properties of element 115, moscovium, can be harnessed to generate gravity. And this is a radical departure from our current understanding of gravity as a fundamental force of the universe associated with mass and the curvature of space-time. And however, moscovium has a unique atomic structure that allows it to interact with gravity in a novel way when specific forces are applied to it. These forces then amplify the gravity generation of the atoms of element 115. In this simulation, the transformation of molybdenum into moscovium involves a tripling process that is adjusted by a factor related to the mathematical constant E, which is the base of the natural logarithm. And this could be seen as a reflection of the fact that the atomic number of moscovium is approximately 2.74 times close to E, the atomic number of molybdenum, and the presence of a neutrino field could potentially influence this process. The neutrinos are elusive particles that rarely interact with matter, but in large quantities and under certain conditions, they could potentially influence nuclear reactions. In this scenario, the neutrino field could provide the additional energy or particles needed to transform molybdenum into moscovium. And the transformation process could involve the absorption of neutrinos by molybdenum nuclei, leading to a change in the number of protons and neutrons, and thus transforming the molybdenum into moscovium. And the factor of E could come into play in the probability of this process occurring, with the rate of transformation being proportional to E raised to the power of the number of neutrinos absorbed. And 15, also known as moscovium, is a synthetic element that is not naturally occurring, and for us Earthlings is only produced in particle accelerators. 15. The current method of producing moscovium involves a nuclear reaction between two lighter elements, typically americium-243 and calcium-48. Here's a simplified version of the process. And so a beam of calcium-48 ions is accelerated to high speeds in a particle accelerator. This beam is then directed at a target made of americium-243 and stayed up. Occasionally, a calcium-48 ion will collide with an americium-243 atom and stick to it, forming a moscovium atom. This process is not efficient, and it takes many billions of collisions to produce even a few atoms of moscovium. And the moscovium that is produced is also highly unstable and decays into other elements in a fraction of a second. But let's take a step back and look at this process from a different perspective. What we're essentially doing is recreating on a much smaller scale the extreme conditions found within a black hole. And the intense pressure and energy of the particle accelerator mirrors the intense gravitational forces within a black hole's event horizon. The fusion of the americium and calcium nuclei simulates the fusion of matter that occurs within a black hole. In this life, our process of creating element 115 is not just a scientific experiment, but a glimpse into the heart of a black hole. It's a testament to our ingenuity and our relentless pursuit of knowledge. And so it's also a reminder of how much we still have to learn. You know, the element 115 we create is unstable and fleeting, a far cry from the stable element 115 that is theorized to exist. And here's where things get really interesting. We look closely at the byproducts of our element 115 creation process. We find a large number of neutrinos, and these elusive particles are incredibly difficult to detect, but they're there in far greater numbers than can be accounted for by the fusion process alone. This suggests that there's more to the creation of element 115 than we currently understand, and it hints at a deeper process at work, one that is intimately connected to the conditions within a black hole. It's as if the black hole itself is reaching out, guiding us towards a deeper understanding of the universe and our place within it. And the aliens have found that the most effective way to harness this property is by creating moscovium in 3 separate pieces, each shaped in a specific way to fit together into a triangle. And this could be due to the specific arrangement of the moscovium atoms within each piece. This is optimized for the generation of gravity when arranged in this triangular configuration. And the process of creating these pieces could be likened to 3D printing, where material is added layer by layer to create a specific shape. In this case, the printing process would involve the transformation of molybdenum into moscovium, likely within the high energy environment of their particle accelerator. And the precise control of this process would allow the aliens to create moscovium pieces with the exact atomic arrangement required for the generation of gravity. Once the 3 pieces are combined into a triangle, a special reaction occurs. And this could involve the release of energy stored within the moscovium atoms, or perhaps a change in the atomic structure that allows the moscovium to interact with gravity in a new way. And the result is the generation of a gravitational field, a remarkable feat that would revolutionize our understanding of gravity and its relationship with matter. Now let's move back to our creation of element 115 here on Earth. And so testing the idea that our particle collider is simulating black hole subtopology effects when creating element 115 is a challenging task given the elusive nature of neutrinos. And this is that no way, however, we can design an experiment that relies on the statistical likelihood of detecting neutrinos rather than directly counting them. Here's a hypothetical experiment baseline for all. First, we need to establish a baseline for the likelihood of detecting neutrinos in typical particle accelerator experiments. And this would involve running a series of tests with different elements and recording the frequency of neutrino detections in each case element 115 production. And then we could next we run the experiment to produce element 115 using the same method currently employed, bombarding atoms of americium with ions of calcium. We would need to carefully monitor the neutrino comparison. We would then compare the frequency of neutrino detections in the element 115 experiment to the baseline measurement in the list. If the elements 115 experiment results in a higher frequency of neutrino detections than the baseline, this could suggest that the process is indeed simulating black hole conditions. Further analysis to further support this hypothesis. We could analyze the properties of the detected neutrinos from the element 115 experiment. And so if these neutrinos have unique properties or behaviors that align with theoretical predictions for neutrinos in black hole conditions, this would provide additional evidence for our hypothesis. Replication. And finally, to ensure the validity of our results, we would need to replicate the experiment multiple times and in different particle accelerators. And the video save. If the results are consistent across multiple trials and settings, this would strengthen our confidence in the findings. This process from discovery to application is a testament to the pattern. So by simulating the, most extreme environments in the universe, these aliens were able to make discoveries that would have been impossible through observation alone. And they turned theoretical possibilities into practical realities, pushing the boundaries of their knowledge and technology. And so in the heart of a black hole, a process unfolds that transforms molybdenum into stable moscovium, mediated by the mysterious Majorana particles. It's a process that could only happen in the most extreme environments in the universe, a testament to the incredible complexity and wonder of the cosmos. And as we continue our journey of discovery, let's remember this. And our process of creating element 115 is not just a scientific experiment, but a window into the heart of a black hole. And that it's a glimpse into the extreme conditions that exist within these cosmic phenomena, and a hint at the incredible potential that lies within our grasp. And the creation of element 115 is not the end of our journey, but the beginning of a new chapter in our quest to understand the universe and our place within it.